Hello learner, welcome to Manifested Online Classes. My name is James Kenyani. We are coming to one of the winding sessions of area approximation, and in our lesson today we still look at further solutions to questions, with the main objective of giving the learner, equip you with skills of answering questions on the topic. So the question in mind is on application. So it is to keep the learner with the skills to solve questions on application of area approximation. Straight to the question. A Formula 1 racing car starts from rest and travels at a uniform acceleration of 20 meters per second for 5 seconds. The car brakes are then applied and it comes to rest with a uniform retardation. Another name for retardation is deceleration. After 8 seconds, draw the speed time graph and find how far the car traveled after the brakes were applied. So we go back to the question. We have 5 seconds there when the car accelerated to the maximum. Then brakes were applied and it decelerated for 8 seconds. So you realize in the solution, you should work out something there to equip you to get the graph. In the solution, we have section 1. You can call it section acceleration section. Acceleration section. We find it comes from rest, isn't it? It comes from rest. And meanwhile here, know that velocity, the speed, the velocity or speed will be given by, so we talk of velocity, is given by acceleration times time. Acceleration times time. So for 5 seconds, it moved with a uniform acceleration. So during that time, speed rose from 0 meters per second to what? Rose to 0 meters per second to 100 meters per second in 5 seconds. In 5 seconds. So here, you'll come and work the acceleration, 20 meters per second squared times 5 seconds. That is where you get your 100 meters per second. That was the first section. In the second section, section 2, you can call it deceleration section. I can call it deceleration section, learner. Speed dropped from. Speed dropped from. The speed dropped from 100 meters per second to 0 meters per second in 8 seconds. After getting that information, it is now easy for me to plot a simple graph for the calculation. So the total journey, so you can write total journey takes 13 seconds. Total journey takes 13 seconds. So you'll use this information to plot your graph. It has taken 13 seconds. So you can use these, the graph. So those are the 13 seconds. A simple graph, time in seconds. Time in seconds. Then this will be speed. Speed. This will be speed in meters per second. Speed in meters per second. So I have 10. Can have 20, 40, 60, 80, 100. So I'll use this information to plot that in the first 5 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So in the first 5 seconds, it is up to here. The speed rose to maximum. The speed rose to the maximum, 100. So you draw this, simply draw this. So when you draw that, you'll have that. So you can come and even write that acceleration section. But after that, we have the deceleration section. The speed then drops to 0 again in the next 8 seconds. So learner, you can write here, this is the deceleration. So you have enough information to solve that. They're asking you, draw the speed time graph, speed time graph, and find how far the car traveled after the brakes were applied. So it is actually after the deceleration, that deceleration. So it will be this section, distance traveled after applying brakes. So learner, that is what we get. The speed dropped from 100 to 0. So the distance will be equal to the distance traveled after applying brakes. Applying brakes, learner, will be equal to, you'll come here, this is 5 to 13, so that is a half. You start with this, a half times 8 seconds, from 5 to 13, that is 8 seconds. Then from 0 to 100 meters per second. 100 meters per second. So this second will cancel with that. 2 goes there, 1, 2 goes there, 4. The distance traveled would be 400 meters. Distance traveled, learner, will be equal to 400 meters. That is the answer to that question. Having gotten that, it would be better to be given 1 or 2 sums for you to go and attempt and get a good click of the applications. So this is the assignment. So learner, in the winding sessions, we have those 2 questions for the assignment on application. We start with the first one. A train starts from rest and accelerates at a uniform rate. Rate is the same as acceleration of 1.5 meters per second squared for the first 20 seconds. It then travels at a constant speed. Draw a distance time, a speed time graph. So this should be a speed time. Draw a speed time graph. Draw a speed time graph, and from the graph obtain the speed after 10 seconds, the distance traveled in the first 50 seconds. Number 2, a truck starts from rest and reaches a speed of 18 kilometers per hour in 1 minute. It then maintains the speed for 4 minutes, and it is then brought to rest in half of a minute. Draw a speed time graph and find the distance traveled by the truck. So thank you very much, and I hope the concepts got in, and enjoy yourself as you continue practicing more questions on the topic. Thank you and bye-bye.